Well, hello, how's it going? This is Ali from the AI Enthusiast, and today we'll be covering Open Generative QA. So this is lecture 3. Let's jump right into it. We have a lot to do. So last time we talked about extractive QA at the top, and basically this is getting the answer from the background information that you provided. Open Generative QA is what we're going to be focusing on today. So it's going to look at the context, the background information that we provided, but it's actually going to generate more text from that. So I'll show an example. Let's move on. So this is a concept architecture that we're going to be working on. It's very similar to the last video where we did extractive QA, but you'll see differences in how the model performs. In particular, like we're not going to get text that is like exactly from the document, like from the context. It's going to be different. So we'll work on that. But basically, we have a bunch of resumes. Step 1, we extract the text from the resumes. Then from there, step 3, we provide a question. And then we have the same interface here. So under the hood inside of the get answer function, I have changed it so that it's using a sequence to sequence model. And that's actually how we will be doing Open Generative QA. I'll get into the details later. And then from there, you get a response, and then you print that response out. So let's move on then. As an example, this is the same context as we showed last time. And so this is a background string on beekeeping. The question is, what kinds of danger does a colony face? And here the answer, it's, in particular, we have this section here. We have potential threats to the colony health like diseases and pests. And so you can see there are several potential threats to the colony like diseases and pests. But then after that, on the flip side, and then it gives us more information. So this is information that's not in the background string or the document, but it is being generated by the model itself. So let's go ahead and let's jump into the code. All right, guys, so basically I already have the Git repository downloaded on my machine, and this is from the last video. If I do ls, I do see that I don't have the latest lecture information, so I'm just going to do a git pull. I will run into some merge conflicts, so just to make it simple, I'm going to do git reset -- hard origin main, because this is the actual branch that I'm on. So now if I look at it, I can see I have lecture 3. So let's get started. So lecture 3 in particular, I actually have an interactive IPython notebook that I have that folks can use. So before we jump into this, let's go ahead and go to readme.md. Let's follow the directions here. So lecture 3 directions to get this up and running. We already have our virtual environment from lecture 2. So I'm not going to follow steps 1 through 7. I just need to activate it. And that's what these instructions are saying. So let's go ahead. I have to go back out of the Git repository. If I do ls, I can see now my environment is my-env, and I just need to activate it. So I'm just going to do /my-env scripts activate. All right, now that I've already have that, I can then go back into my Git repo. I can go into, before I go into lecture 3, I should just finish up these directions. So basically when I do activate, now you can go into lecture 3, but over here, we have to follow, instead of 1 through 7, we have to follow .scripts activate. So it looks like I need to modify these directions a little bit. I do need to run step 7 here because I added some more requirements, required dependencies. Let's go ahead and do that. So this is going to download everything for me. All right, we're done installing. So now let's go to step 2. So we just have to cd into lecture 3. So cd lecture 3. And then inside of there, we can learn the concept. So we're going to use the interactive Python notebook. And then after that, we'll actually run the code on the resumes. So let's go ahead and actually open up the interactive Python notebook. You can just open it up natively inside of VS Code. And I will just disable this for a second. Okay. All right, so the first thing is we're going to import the datasets and then the transformers libraries. If you press Shift-Enter, Python environments, we're going to use the my-env that we've set up already. All right, then we're going to go to downloading the dataset. So this is downloading the squad dataset. This is a common question answering dataset, and this is just to show you like the format of it. So let's go ahead and download it, and we can explore a little bit. We can see here QA sub 0. So that is, there's an ID to this data point, and then we have the title, we have the context, this is the background string, and then we have the question, and then we have the answer, and then we have the character index of where that answer is present. So that's what QA sub 0 this is, and then you have a bunch of these. And so as you can see, that's the squad data set. Now let's go to instantiating the model. So the key thing here, guys, for like the question answering portion, like where we're not generating, we're not extracting text from the PDF, but we're actually generating on our own. We're going to be using a sequence-to-sequence model. So over here, I have text-to-text generation. This is the model name, BART ELI 5. Explain it to me like I'm 5. And this is using a BART-based model. So all that means is we are feeding in text, a sequence, and then we are getting back a sequence. So you'll recall from the previous video, when if you go ahead and take a look at that, you'll see that we're using a different model for that. That's specifically for extractive QA. This model here is specifically, you're going to provide the question and you're going to provide the context, the background string, and it's going to generate based off of the context, but it's going to generate free text. So this right here is a 1.63 gigabyte model. So when you download this, it's going to take some time. All right. So now from here, I can show you the model, and this is the architecture of the model. It is a PyTorch model, but I'm going to skip the details here. It's not relevant for developing an application, but let's go ahead and actually try an example. So over here we have a context. So this is in the context list. I just took the first one, and I have it pretty printed here for us. So I just print that, and then from there I have my question. So I'm actually going to ask the second question, and that is which football team won the Super Bowl in Super Bowl 2015? So as can be seen here, it was the Denver Broncos. They defeated the NFC team, Carolina Panthers, and this was basically Super Bowl 50, 2015 season. And the actual event happened on basically in 2016, and as usual in February. So let's go ahead and press play or shift enter. So the way we actually call in this model, we have the actual string that we're going to provide it. We have the question, and then we have the context. So it's going to put in both of those things. And then num beams do sample temperature, max length. The main thing to look at least for the purpose of this video, is temperature. Increasing the temperature allows you to add variability to the text that's generated. Decreasing it makes it more strict, like less likely to explore the space of text that can be generated. So you can see here, the Patriots won the Super Bowl in Super Bowl 2015, and that's not true based off this context. So if I reduce this over here, let's see if it gets it this time. And if it doesn't, that's fine. This is that's where the limitations are. Extractive QA is going to get something specifically from the text, whereas generative, this other approach that we have, this open generative QA, it's going to be getting data not only from the text, but also just generating on its own from what it's seen. So this is all saying Super Bowl. And so if you're looking for a specific text, guys, like short answer, in this case, it would just be as simple as saying Denver Broncos. It would be probably better to use, your extractive QA from the previous video, because it just generates the string from the text that we provide. But what makes this generative QA shine is basically the second example, where we are asking more of an open-ended question. So why did they remove the Roman numerals in Super Bowl L? So L stands for 50. They branded it as 50, so it was a little bit more emphasized. It's the actual text here explains what's going on. But yeah, so I'm just going to go ahead and print this out. Let's see how good it does. And I kept the temperature kind of higher. So let's see the response that we get from here. Okay, so they didn't want to give too many pennies, I guess too much money, and they don't want their product associated with a bunch of pennies. So yeah, so you can see this doesn't really make sense. Let's go ahead and actually reduce this. And it's a very large model, so it takes some time. Yeah, so you can see how the model doesn't necessarily understand this context, but then again, this model isn't ChatGPT. So yeah, let's actually pause here. I know there's a lot to cover actually for the application stuff, so I'll break that into a separate video. And as for this, I encourage you guys to take a look at the code, download this, and then open up the Python notebook and then play around with it. As you vary the temperature, you're going to see different results, more accurate versus less accurate. So it's a good way to learn and also just to get a feel for how these models work. So thanks again. If you like this video, please like and subscribe. It really helps the channel. And if you have any other questions or comments regarding this video, please post them at the bottom. And take care. See you next time.